Welcome to the introductory tutorial for PhotoModeler shape-based projects. In this tutorial, we will work through the basics of setting up and producing a shape-based 3D model in PhotoModeler. We start by selecting Shape-Based Project from the Getting Started dialog. Browse to the folder where the images are stored. And add them to the project. After clicking Next, PhotoModeler has searched our camera library but was unable to find a calibrated camera that matches the images we have selected. One of the powerful features of Shapes is the ability to calculate some of the camera parameters, in addition to a camera and object's 3D locations. If the images come from a known camera, and a calibration has or can be done, it is recommended that you use the calibration. However, in this case, our images come from an unknown source. We select an unknown camera, solved by Shapes, and click Next. When opening a Shapes-based project, the Shapes toolbar will be displayed with the various primitives we can mark. Additionally, the Processing button changes to include a blue cube indicating shape processing will be done. This algorithm is completely separate and different from the processing that occurs in points-based projects. We will double-click to open Photo 1. This photo shows three basic shapes as examples. We'll click to add a box shape to the project. We now need to mark this box shape on the photo. We rotate the box so its orientation approximately matches the photo. This will make it easier to visualize when marking. The front bottom edge is highlighted in red. This is the edge we need to mark. When in vertex marking mode, the vertex to mark will be indicated by the red ball. We move to Photo 1 and mark the front bottom edge here. Once the edge is marked, it automatically advances to the left bottom edge. We mark it here. It is now advanced to the back bottom edge, which we cannot see in this photograph. We press Escape to go to the next edge. We can't see this edge either, so we press Escape again. This edge we can see and mark it here. And this one, mark here. The back one we can see here. Once that edge was marked, there was enough information in the scene for the shape to calculate and solve. The camera position and focal length have been calculated as well as the parameters for the box. You can see the box shape has changed from an unsolved cube to match the shape we have marked. We can mark this back corner to strengthen the solution. We switch to Select mode and open up a 3D view. Here is the solved box shape. If we turn on camera stations, we can see the camera's position has been solved. If we turn off camera stations and turn on fast textures, the shape grabbed its textures from the oriented photo. We can turn on the visibility of the shape edges and vertices. See the wireframe version of the shape. All this was done with a single photo from an unknown camera and these markings here. Now we add a second box to the scene. The box lies on the ground plane. Since our camera position is now solved, Box 2's view in the Shape Explorer automatically lines up with the photo. We mark the front edge of the box here. We can't see the back side or this side. We mark here and here, following along with the red line and ball. When we click this last point, the shape has enough information to solve, and you can see its calculated position in 3D. Next, we will mark the last corner And then we'll add this wedge here. We click to add a wedge to the project. When you have an existing shape selected and try to add a new one, by default, they will be added stacked on top of the selected one. In this case, it is not what we want. Before adding the wedge, we could have unselected any of the existing shapes, or we could just change the shape of the ground plane like the others by clicking here and selecting Lies on Ground Plane. We click OK to add the wedge to the project. Just like with the boxes, we now mark the wedge on the photo by indicating which edge is the red highlighted one. The front bottom here, the side here. This point we cannot see in the photo. We can press Escape to advance to the next edge, which we cannot see either. Mark the top point and the last point here. Once there's enough information available, the wedge's position is calculated. If we open up a 3D view now, you can see all three shapes, relative dimensions and positions, are calculated. The parts of the shape that face the photo are textured. The backsides that do not appear do not have textures. You can assign a specific material to a face. For example, we can select this face to make it white. We'll set it back to the textured material. If we have a second photo showing the backsides of the shapes, the textures can be grabbed from the second photo. We'll save this project. Go to File, Save As. Save the project as singlephotoshapes.pmr. This file is included in the tutorial samples. We double-click on Photo 2 and select Box 1, which is the wooden box. If we want to make it easier to identify the shapes, we can rename them. We click Rename and type Wooden Box. Photo 2 is looking at the back of the box. To make it easier to visualize which edge we need to mark, we'll rotate the box to look at the back and arrange its orientation so it is approximately the same as the photo. Switch to Shape Marking mode and mark the edges of the box which we can see. Start remarking the bottom of the back here. Bottom side, this side. And front edge here. When we mark that edge, the photo now has enough information to orient, so PhotoModeler knows where the photo was taken from. You can tell the photo is oriented by the camera icons on the thumbnails here and the text on the title bar here. Since there is now an oriented photo showing the backsides of the shapes, if we open a 3D viewer, we can see that all sides are now textured. We select Box 2. As this photo's position is now solved, the Shape Explorer has now automatically positioned Box 2 so that we're looking at a view that matches the photo. The back bottom edge is here. We mark it now. If we want to mark the shapes more accurately, you can zoom into the photo. One method for zooming is to hold down the Alt key. Alt Zoom brings up a magnified window of the area around the current mouse location. We press down Alt and click to mark the vertex here. This one here. The top one here, there, and we can't see this edge, so we press Escape to advance. And mark this corner here. The final corner we can see there. Lastly, we will mark the wedge on the photo. This edge here is not visible. We can press Escape to advance to the next edge, or you can select an edge you wish to mark. We mark this edge here. Here, and again we can't see this edge, so we can press Escape or select the top edge. And mark it here. We can switch to Select mode and improve the vertex mark locations. We can use the Alt Zoom as we did previously. Drag the point to its correct location, or we can use one of the other zoom techniques, such as using the plus and minus keys to zoom the entire image. A similar method is using the scroll wheel on the mouse. If you hold down Control and right-click drag, you can pan the image, or we can use the scroll bars. The points in Photo 2 look good. We can review Photo 1. Again, we can use the Alt Zoom. Or press Control and hold the left mouse button down and drag a region to zoom that entire region. As we drag a vertex point, it causes the shapes and camera positions to recalculate. The shape positions are now more accurately placed. We'll save this project as 2photoshapes.pmr. This project is included in the tutorial samples. Zoom this photo to fit. Now we will add a scale to the project. The scale is a single known, real-world measurement. We bring up the Scale Rotate dialog. Go to the Units and Scale tab, select our units as centimeters. Enter in the known measurement of 9.5 centimeters. Select the edge of the known measurement and press Define. After hitting OK, the scale and units are set. If we bring up the Measure pane, objects that are selected have their measurements displayed. The edge we use for scaling is 9.5 centimeters. This edge here is 6.8 centimeters. It can measure photographs, or if you open a 3D viewer, you can also measure here. For example, this face is 8.75 square centimeters. This edge is 9.5 centimeters. This face is 43.4 square centimeters. All of this 3D data, the scale and textures, can be exported for use on other 3D applications. To do this, select File, Exports, Export Model,